Hello, in this video we're going to learn how to find the GCF of a polynomial, specifically factoring out the GCF. We have a couple quick steps. One is we look for the GCF of all the monomial terms. We're going to write down this GCF, and then we're going to literally factor it out. So in parentheses we're going to write the new polynomial, dividing each term by the GCF. So just to review, let's do a multiplication, a distributive problem. So 3x times 4x, and then 3x times negative 5. 3x times 4x is a 12x squared, and then 3x times a negative 5 is a negative 15x. Now the concept in this lesson is on factoring out a GCF. So what we're going to ask ourselves is, what is the GCF of 12x squared and 15x? And I hope you see that the GCF is literally 3x. GCF of 12 and 15 is 3. 3 is the biggest number that divides into 12 and 15. And x can be divided into x squared and x. So we write the GCF, and then we write parentheses, and now we literally divide 12x squared by 3x. So let's do this where we have a little bit more space. So let's write 3x, and we're going to divide each of these terms by 3x. So 3x times, well, what's 12x squared divided by 3x? That's going to be a 4x. What's negative 15x divided by 3x? That's going to be a negative 5. So our final answer of factored form is 3x times the quantity, 4x minus 5, which was our original problem. So now we're going to start off with actual factoring problems. We're going to first try to identify the GCF, and I try to segregate my thinking. So what's the GCF of 4 and 18? That's going to be a 2. What's the GCF of y squared and y? That's going to be a y. So 2y times some quantity. 2y divided into 4y squared is a 2y, and 2y divided into negative 18y is a negative 9. Now one thing which I didn't say in the instructions is you always should check. Right? You should always check. And the way we check is by multiplying. So very quickly, what's 2y times 2y? That's 4y squared. What's 2y times negative 9? That's negative 18y. Let's do the next one. Now here there's 3 terms. So you have to actually look for the GCF, the greatest common factor of all 3 terms. So we have 3, negative 15, and 9. The GCF of 3, negative 15, and 9 is 3. Now what can go into x cubed, x squared, and x? That is an x. So 3x is the GCF. 3x goes into 3x cubed, x squared times. 3x goes into negative 15x squared, negative 5x times, and then 3x goes into 9x, positive 3 times. And again, you can multiply this out to check your answer. Next, we have something with multiple variables. Multiple variables. So again, what's the GCF of 12 and negative 18? That is a 6. Now, how about x squared and x? The GCF of x squared and x is x. The GCF of y and y squared is y. So our overall GCF is 6xy. 6xy goes into 12x squared y. Well, 6 goes into 12 2 times. X goes into x squared x times. And y goes into y just once. So I'm not going to write a 1. 6 goes in negative 18, negative 3 times. X goes into x once, and y goes into y squared y times. So this is my final answer. 6xy times the quantity, 2x minus 3y. Now what if we have some really large exponents? Well, the rule stays the same. We just follow the procedure. What's the GCF of 40 and 50? That is 10. Now what's the GCF of x to the 17 and x to the 15? That would be x to the 15. This confuses some students because it's not like 15 goes into 17, but x to the 15 goes into x to the 17. So now we write our parentheses. 50 divided by 10 is 5. X to the 17 divided by x to the 15 is x squared. Now 40 divided by 10 is a plus 4. And x to the 15 divided by x to the 15 is x to the 0, or just 1. I'm not going to write that at all. So this is actually my final answer. 10x to the 15 times the quantity, 5x squared plus 4. 4. Now how about this last problem? This one might be kind of interesting, and I'm just going to write out some factors. We have a 2 times 3, which is 6. We have an x times x, which is x squared. And what do we have over here? We have a 3 times 3 is 9. We have an x. And then over here is a 2 times 2. So I see lots of common factors. Lots of common factors. I see a 2 over here and here. I see a 3 here and here. And I see an x. But is there an actual common factor that's common to all three? What is the GCF? Well, 2 does not show up in all three of these terms. 3 does not show up in all three of these terms, and x does not show up in all three of these terms. The GCF is 1, so we call this prime. This cannot be factored. Cannot be factored. Now this trinomial cannot be factored with a GCF. It is possible that we can find some other factoring routine to factor this, but it cannot be factored with a GCF. Okay? So those are the steps. Good luck.